Hello, this video is on section 2.8, which is titled Two-value Inequalities. This is in the Algebra 2 textbook, and learning target is to graph two-variable inequalities. Now, a linear inequality is basically a linear function, but instead of a y equals, it's a y and then an inequality symbol between whatever the y is and the equation. And it has two different variables, so the y is on one side and the x is on the other. And when you graph that inequality, there's going to be a region on either side of the line that's going to be a shaded in, or it could be known as the solution of that inequality. So the inequality symbols that we're going to be using are: this is less than, greater than, less than or equal to, greater than or equal to. These are the four different types of inequalities that we're going to be using. I don't think in this section we'll use not equal. That's technically an inequality sign, but I don't think we'll be using it in this particular section. We'll definitely be using it later in the semester. So instead of seeing an equation that looks like y equals 2x plus 3, and you have to graph that line, and the only thing that exists is what's on that line, what you may find is an inequality where you have y is less than 2x plus 3, and this is where you still take the same path on graphing that line. So you have a y-intercept of plus 3 and then the slope of 2, and that is the equation of the line. However, when it comes to an inequality, the only thing that exists is not just on the line. There's going to be something either on this side of the graph that also exists, or this side of the graph that exists. And a way we determine which particular side that is what's called a test point. And a test point is a point that you pick on that graph that doesn't fall on the line or equation that you drew, and you plug the coordinates for that point into the equation, and if whatever you figure out is to be true with the inequality statement, then that means the point you picked falls on the correct side or the correct solution of that graph. If it doesn't, then it means that the side that you picked is wrong and you have to shade the other side. So if, for example, we say that y is less than 2x plus 3, I'm going to pick the easiest point as my test point, and I would always suggest you do this if you can. The point 0, 0 in this case is not on the line, so that's what I'm going to use as my test point. So I'm going to plug in this 0 for my x and this 0 for my y. 2 times 0 is 0. Then I add 3 to 0, and I have 0 is less than 3. Since this statement right here at the very end is true, that means this test point that I chose that falls on this side of the line means this entire side of the graph is a correct solution. That's where I shaded it. If, for example, the side that you picked is false, like if this one we got 0 is greater than 3, that would be false, so we would shade the other side of the equation. And one more thing when it comes to the actual lines that you're drawing right here, when you have less than or greater than, these two mean that you're going to have a dashed line for the equation. So since this was y is less than, that means that this line needs to be dashed. It's not a solid line. But then if you have these which are less than or equal to, greater than or equal to, that means it is a solid line when you're drawing them. Alright, so test point that you pick on the side, if you get it to be true, shade that side. If you get it to be false, shade the other side. But that's what we're going to be doing in the examples in class, and we'll go over them together. Alright.